Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over how to solve problems with density. So let's get into this. So I have three problems, and so we'll start off with the first one. So here you have an object that has a density of 8.95 grams per milliliter. You know this is density because density is mass over volume. So if you write the formula, I'll write it up here. So density is equal to mass over volume. So you can see the units is a unit mass of grams and a volume unit of milliliters. So grams over milliliters is density. So we are given this density, and we're also given the volume of the object as well, which is 6.2 centimeters cubed. Now, right away, you're thinking, okay, they're giving you milliliters and they're giving you density, and they want to find the mass. What's the mass of this object? Well, we're given a volume in centimeters cubed here, but as I said, here we're given the volume in the density unit as milliliters. So how do we do this? Because we have milliliters, we have centimeters cubed. Well, one of the things you need to remember is this relationship here. This is going to be really important. 1 centimeter cubed is equal to 1 milliliter. So that is the relationship. So even though we're given centimeters cubed here, 1 centimeter cubed is the same as 1 milliliter. So we can easily convert centimeters cubed to milliliters. So then I'll write that here. So 6.2 centimeters cubed is going to be equal to 6.2 milliliters. Okay. So why is this equal? Well, it's defined that way. So if I have a cube of water or a cube of some substance, oops, I'm not drawing my cube correctly, so let's go here. All right, so there's my cube. So if I have 1 centimeter across this way, and I have 1 centimeter going back, and I have 1 centimeter high. If I multiply the width times the depth times the height, that'd be 1 centimeter. Oops, that should be centimeter. So if I multiply 1 centimeter times 1 centimeter times 1 centimeter, that's going to give me 1 centimeter cubed. So 1 centimeter cubed, but this volume we make it equal to 1 milliliter. So that's always going to be the case. So now that we got that out of the way, there's a couple ways to solve this. One is to use the equation D equals mv, right? So density equals mass over volume. So here I have density equals mass over volume. I'm looking for the mass, so I can solve this equation for mass by using algebra. And the way I'm going to do that is by multiplying both sides by the volume, V. So I'm going to multiply by V. I'm going to multiply by V here. So volumes cancel out. Oops, that's not supposed to happen. I got a little bit excited. Got crazy with the cancellation. So that's going to cancel out. And then what I'm left with is mass is going to be equal to the volume times the density. So then all I do is I plug in my value. So I have volume. So volume is 6.2 milliliters. And I'll multiply that by 8.95. That's going to be grams over milliliters. And notice right away that I have milliliters on top and milliliters on the bottom. So milliliters is going to cancel out, leaving me with grams. which is what I want. Mass, I want a mass unit. I end up with grams, which is a math unit, so I know I'm good. So then I just do the calculation. Let me do that really quick. And the mass is equal to 55.49. Okay, now that's one way to do it. Another way to do it, as we chemists like to use, are conversion factors. So if you're taking a chemistry class, you're going to want to use conversion factors. So this is how you use conversion factors. Remember, whenever you're given a unit per another unit, or a unit related to another unit, or something per something, that's a conversion factor. You can use that as a conversion factor. So here we have density, grams per milliliter. Density can be used as a conversion factor. So let's show you how this is done. Just to give myself some room, I think I can do it here. So I take what I'm given. So since my density can be used as a conversion factor, I'm not going to start with that. I'm going to start with the other thing they give me, which is the volume. So I'm going to take the volume. And so here I got 6.2 centimeters cubed. I'm going to put that over 1. I'm going to set up my conversion factor. Well, density is the conversion factor. So I'm going to set this up so that centimeters cubed is on the bottom. Or better yet, make this milliliters, since my density is in milliliters. So here I want milliliters on the bottom. So for every 8.95 grams, it's 1 milliliter. So I'm going to put 1 milliliter on the bottom, and then 8.95 grams goes on top. So milliliters cancels out again, and voila, I'm now multiplying 6.2 times 8.95 grams, divide by 1, but you don't need to, and I get the exact same answer. Okay, what about problem number 2? So here it's giving me, it asks, what is the volume of an object if the density is 2.73 grams per milliliter and its mass is 12.5 grams. So very similar to the last problem, except this time they want the volume and they're giving me the mass. So same thing. I can either use the equation, right? So in this case, density is equal to mass over volume. And this time I want the volume. So I need to get volume by itself. So I'm going to use algebra. So I'm going to multiply both sides by V again, because I want V on top. I can't solve with V on the bottom. That's not how it works. So I need to get V on top. So I multiply both sides by V. So that's going to cancel out. So now I have mass is equal to volume times density. But now I want volume by itself, so I need to divide by density. So now density cancels out, and I have m over d. So the equation I'm going to use is volume is equal to mass divided by density. So then all I do is I plug in what I have. So I have mass, so 12.5 grams, over the volume, which are the density, 2.73. So 2.73 grams per milliliter. This time grams cancels out. I'm left with milliliters. And then when I solve the equation, what did I get? I get 4.58. So I get 4.58 milliliters. Okay, so again, that's using the equation. But I can also, again, use density as a conversion factor. So let me do that. I'm going to go ahead and erase this because I don't have any room. And let's show you the conversion factor method. So again, same thing. Since this is a conversion factor, I can use that later. I'm going to start with grams. So I take the 12.5 grams and I put over 1, and I start to multiply using a conversion factor. So this time, grams is on top, so now I want grams on the bottom. So I'm going to take 2.73 grams, put that on the bottom. 2.73 grams. And then I'm going to put 1 milliliter on the top. So now grams cancels out, and I'm left with milliliters. And look, I'm dividing, again, 12.5 divided by 2.73, multiplied by 1, divided by 1. Again, you don't need to multiply and divide by 1. You can skip that. And then, again, you get the same answer. What did I say? 4.58. 4.58 milliliters. So same answer as before. Okay, number 3, last but not least, here they're asking what is the density of a block if its mass is 62.3 grams and it has the following dimensions. So 13 centimeters long, 4 centimeters tall, and 7.5 centimeters wide. Okay, so in order to calculate density, right? So density is mass over volume. We're going to need mass and volume, and that's what they gave us. So, but you're going to ask, Mr. Koval, did they give us volume? They just gave us a bunch of lengths. Well, if you remember what I said here, you have a box here, you have a height, you have a width, you have a depth. You multiply those 3 together, you get a volume. So here, they're giving you the length, the height, and the width. Multiply those together, you get the volume. So volume here is equal to the length times the width times the height. So we got 13 centimeters multiplied by how wide? 7.5 centimeters times the height, tall. So 4 centimeters. Make sure I wrote that down correctly. Yep. Okay. So now all we need to do is multiply those together, and we get, what did I get? 390 centimeters. So this is equal to 390 centimeters cubed. And notice again, remember, so not only are we multiplying the numbers together, but we multiply the units. Centimeters times centimeters times centimeters gives you centimeters cubed, right? So now we have the volume in centimeters cubed. Remember, we can keep these volume in centimeters, or we can make it into milliliters. It doesn't matter. Centimeters cubed is also used in densities as well, especially if you're measuring the density of a solid. And so now we have the mass. So we can take the mass. So here we can just take density is equal to the mass, which is 62.3 grams. Divide that by the volume, which is 390 centimeters cubed. And then when we calculate that, we get, what do we get? We get 0.160 grams per centimeter cubed. So that is our answer. And so that, ladies and gentlemen, is how you solve problems with density. If you enjoyed this video, if this video taught you something, and if you learned anything from this video, then please by all means like the video. Hit the video, subscribe, hit that hit that like button over there, hit the notification bell for the videos that I put out. So when you hit the notification bell, make sure you hit all so you can be notified by all the videos that I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me and have a great day.